Today we're going to review the laws of exponents. We're going to start off by just reviewing the basic laws, and these are on your formula chart. So if you have the same base and you're multiplying, you add those exponents together and just keep the base how it is. So those being the same bases is the most important thing for you to notice. So if I had a to the 6th power times a to the 3rd power, that would give me a to the 9th power. Second one we're going to review is the division rule. So again, same bases. So if I had b to the 6th divided by b to the 3rd, we would take this top exponent, subtract the bottom, so that would give me b to the 3rd power. Third rule we're going to talk about is the power rule. So if we have a base raised to an exponent, that's again raised to an exponent, we multiply those two exponents. So if I had c to the 6th power raised to the 3rd power, I would do 6 times 3, and that would give me c to the 18th power. So then we're going to talk about a negative exponent. So we can't leave things as a negative exponent. Anytime you have a negative exponent, you're going to flip it to the other side of the fraction bar. So again, if it's like anything's over 1, so you would flip it to the bottom of the fraction bar. Conversely, well, I'll show you an example. So first example for this, if I had d to the negative 2, we would rewrite that as 1 over d squared. But second example, if I have something like 4 over y to the negative 3rd, so you'll notice on this one, the negative exponent is already in the denominator. So it would flip and get to go up on the top. So it would become 4y to the 3rd. Next is the power of 0. So any number to the power of 0 equals 1. So I'm just going to say any number to the 0 power equals 1. So if I had 4 to the 0 power, that'd be 1. If I had 515 to the 0 power, that would be 1. The last one that we don't really, I haven't seen a lot in Algebra 1, especially on the EOC, but this is on your chart. If you have a fractional amount, then the numerator is inside of the radical, the denominator is the index of the radical. So one example would be like 27 to the 2/3 power would be written as this, it's actually the cube root of 27 squared. And so you could see something like this on your EOC, in which case hopefully you would think that that was like a really easy gimme answer, because we could go math down to number 4, so it's the cube root of 27 squared, and hit enter, and we would get 9. So that's just calculator skill once you know how to rewrite this. But to be honest, you could type in 27 to the 23rd power by going 27 caret and then parentheses 2/3, and guess what? It's 9. So we'll do one that has a variable, so it's not as easy to just type into the calculator. So e to the 3/4 power would be rewritten as e to the 3rd power underneath a radical with an index of 4. So the bottom number gets to be the index, the top number is the exponent under the radical. So kind of the culmination of all of these rules is this multi-step example. So I'm going to start with this power rule first. I'm going to try to write all my steps and hopefully I can get them to fit. So I'm not doing anything with the top right now, so I'm going to leave that how it is, and I'm going to focus on distributing this power to every single part. When we do that, when we distribute that power, remember the power rule says we're going to multiply. So it would be 2, right now it's the 1st power, so 1 times 3 would be 3. X to the 0 power, so 0 times 3 is 0. and anything to the 0 power is 1. Then we'd have y, right now it's to the first power, so it'd be y to the third power, times 2 to the third power, times 3 times 3 is 9, so x to the ninth power. And then 1/2 times 3 would be y to the 3 over 2. Okay, so that's where we're at this moment. Now I'm going to kind of simplify. So step 2, I'm going to simplify. We'll leave this alone for a second on top. So I know 2 to the third power times 2 to the third power is going to give me 64, because this would be 8 and 8. So 8 times 8 is 64. Then anything times 1 is itself, so we're kind of done with that. Then I'm going to go with x to the ninth. And then I have these y's, and they're multiplying, so I would add the exponents. But here's the deal. When you add 3 plus 3 over 2, you have to have a common denominator. So this would make it 6 over 2. So when you add, it would be 9 over 2. So it would be y to the 9 over 2. So did a lot of there. Now we're going to deal with this negative exponent. So this is a negative exponent, so it needs to flip to the bottom. So it would become y to the fifth over 64. So if we flip this to the bottom, we would be basically multiplying it by x to the fourth. So we would add those. So it would give us x to the 13th, y to the 9 over 2. So when we divide exponents, so we have this y and this y are being divided. So when we divide, we subtract. So it would be 5 minus 9 over 2. So again, got to have common denominator. So 10 minus 9 is 1/2. So this positive 1/2 is the exponent on y now. So y to the 1/2 over 64x to the 13. So last thing we're going to do is deal with the fact that this has a 1/2. And so it would be y to the first power underneath an x radical with a index of 2 over 64x to the 13. Or you could see that as square root of y over 64x to the 13. So that was hugely long and had a lot of steps, but it basically covers every single rule of exponents. So that's just a real quick review of exponents.